What's going on, seventh graders? Hey, miss you guys. I know it's weird not having me or Miss Watson there. If y'all get a chance, can you go by and just tell Miss Moore thank you so much for doing all kinds of extra work for our science group department and stuff? I think she'd really appreciate it. I know she's crazy and kooky, but we all are. And sometimes Miss Moore just needs some encouragement. So go give her some love today. Just tell her thank you for all that she's doing while we're gone. And we're going to go over the Venn diagram that we've assigned to you. So if you really need to, you can basically watch this video with me and use it to fill out your Venn diagram, kind of like notes. But we wanted to give you guys something where there's some explanation that explains why these things are written where they are, not just copy and pasting notes, basically. So we're comparing elements, compounds, and mixtures. And these notes are from your notes from Friday. These are statements that were made on that note packet. So you should be using the notes to answer these. And really, we're getting you to separate out information and show where things are similar and where they're different. That's the whole idea. So elements and compounds. Well, an element, you got kind of your definitions that are staying true to that specific type of state of matter. And when we say state of matter, we're not talking about solid, liquid, gas, but we're talking about isolation, like element by itself, compound, different elements together, or mixture, different elements and compounds all together in a big mix. So elements are pure substances that can't be broken down into any other substance. That doesn't mean that they're not bound together. For example, hydrogen gas is H2. And so there's one hydrogen and they're together. It's still only hydrogen. So we consider that an element. And it's a molecule because they're bonded. But we would call that an element because it's only one substance and it has only one characteristic for hydrogen. There's not any new set of characteristics for that state of matter or for that form of matter. Okay. It's represented by the boxes on the periodic table. And we know that because we really have already studied a lot about elements, right? So the example in our notes was gold, and it's got a symbol AU. And so that's a metal element. It can be by itself and isolated. You can have lots of those, like aluminum, that are in aluminum cans. And so there are metals that can be isolated. They're bonded, but they're all one type of element. And you can have something like carbon, which is like a diamond or even charcoal. That's all carbon that's bonded, but it's still carbon. So an element is just one element. And they have their own properties. Each of those elements have properties of them that are really important. Okay. You'll notice that elements and compounds are still both pure substances. And what that means is they have their own set of characteristics and properties. So even compounds, when you combine elements, they still have their own characteristics and properties, meaning they behave a certain way, they look a certain way, and they do certain things. And the same thing is true for elements that are by themselves. A compound also is a molecule, can be a molecule just like an element. All compounds aren't molecules. And just so you know, a molecule is when you have basically non-metals that come together in a compound. But you can have a molecule that's an element like hydrogen, carbon, or hydrogen, helium, or even oxygen. Or you can have a compound that's a molecule like water, H2O, or like glucose, which is sugar. That's all non-metals, so it's still a molecule. So both elements and compounds can be molecules, and both elements and compounds are pure substances, meaning they have their own set of properties. So it's kind of like an identity, right? All of us are different students. We might have similarities, but we're all different people with our own set of properties. And I mean, we're a lot more different than molecules, but we kind of behave certain ways based on who we are. Well, elements and molecules have their own identity, and they behave the way they do because of properties that they have. And that all comes from them being what we call a pure substance, meaning they're going to have that same type of property no matter what. And that means so all glucose molecules act like glucose, and all water molecules act like water. They're pure, and they're always going to be the same. Okay, an example of a compound is NaCl, which is table salt. So that's sodium and chlorine. We call it sodium chloride. So it means we have a sodium molecule, we have a chlorine molecule, and they bond together. And now they have new properties as that salt molecule. So it's kind of cool, actually. And there's tons and 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 tons of compounds in nature. In fact, most elements are found in a compound and divided through chemical means. So all of these are made of matter and made of elements. So if we go back to what we have been studying this whole time, we're still talking about physical matter and what it's made of. So we went from super basic, one, like how does matter behave, whether it's in a compound or it's an element, solid, liquid, gas, how does temperature change it? Okay, so the behavior of matter. Now we're looking at what makes up matter? Well, we started with elements, which are basic, and now we're looking at different forms of matter, because matter doesn't just behave with temperature, but they behave with each other, right? So it's just like us as human beings. Like, I'm going to dress different if it's hot outside because the environment affects me, but I also might dress different, like if I'm taking my wife out to a really nice dinner, because I'm interacting with another human being. Well, matter's the same way. Matter is going to change based on the environment, but also based on other matter in its vicinity. So they react with other forms of matter. And that's kind of where we're headed as we learn about these different types of matter. So it all matters. It's all really important. And so elements, compounds, and mixtures are all made of matter, and they're all made of elements because elements are the basic form of matter that we see in the universe. Yes, each atom is made of subatomic particles, but those subatomic particles don't have as many properties as those elements themselves have. So we talk about elements as like the basic form of matter. And that's why you see those two things in the middle where they're a part of all three. Okay. Then you have mixtures, and mixtures are the most complex, which means they have the most kind of differences, right? It's almost like a completely different thing. Well, really, it's just made up of the other two. So a combination of many different elements and compounds. So a mixture could have single elements in it. It could have compounds in it. It can have things that are floating and not dissolved. It can have things that are dissolved. It can be mixed all together. It can be separated out. But a mixture is a combination of different elements and compounds. They are not chemically combined. They're physically combined. So that means that there's not a reaction that happens when we put these together. We physically make them come together. So we're either going to pour salt in water. That is a mixture, believe it or not, salt water. And it has when it goes in the water, it has water, it has sodium, and it has chlorine, because they actually separate out. So you have two elements and a compound all together in a solution, which is another word for a mixture, whenever things are dissolved. Okay. A heterogeneous or a heterogeneous potato is where you have differences. So it doesn't all look the same, right? So like trail mix is a great example, right? Because I can see the M&Ms, I can see the peanuts, I can see the cashews, I can see the pretzels. I can see all the parts of that mixture already separated out. So if I wanted to pour it out, I could literally separate it out myself. A homogeneous or a homogeneous mixture, you cannot see the parts. They're all mixed together. And the best example of this is really milk. But like I said, salt water, that salt is dissolved, so you can't see it. It's all clear. You can taste it, but it's all clear. But milk has so many different molecules and compounds inside of it, and it just looks like a white liquid, right? So milk is a really good example of a homogeneous mixture. Now, all mixtures can be separated out. And so we can take all these things out of a mixture. It's just when it's heterogeneous, it's much easier. When it's homogeneous or homogeneous, it is really more difficult to separate out those things. So, an example, though, of that happening is milk. So, when you go to the store, you can see that milk, there's 2% milk, and there's 1% milk, and there's skim milk. And I mean, even today, now there's like cashew milk and all these other milks. But the reality is, the percentages that they're talking about, that has to do with fat and some of the molecules that are in the milk itself. And they use physical processes to separate out some of the fat in the milk, and they take it out using these processes. And so it's still a homogeneous mixture, but they can make milk more healthy, or I say more healthy because some people just need less fat. But they basically manufacture these milks by separating out parts of a mixture. So it's actually kind of neat, right? And that's our notes basically over the Venn diagram. And we're looking at, right, compare and contrast. So what's the same? That would be comparisons. So the pure substance and the molecule, those are comparisons between elements and compounds. And those are two things that they have in common. And then all three of these are made of matter and made of elements. So we're still talking about matter, just to remind you. And that's what's super important is so much of what we learn in science deals with matter because it's what we mess with. It's everything that we live in, right? And then mixtures are really very, very different, right? So we're looking at heterogeneous or heterogeneous and homogeneous or homogeneous mixtures. And we'll talk more about those later this week. Okay. So hopefully after watching this, you can complete your Venn diagram and you'll understand more about what we're teaching you in terms of how these three things are similar and different. And then tomorrow, we're going to have an activity where we start understanding how compounds are made. So you're going to be given sets of elements on a digital lab, and you'll make different compounds. So I'm excited about that. Hopefully, you guys can learn more. I'm a chemistry nerd, and so it's kind of the step one for chemistry. You guys have a great day. I hope you enjoyed learning more about this and not just copying down some notes. And then if you need to slow down, I would just screenshot all this information right here at the end. You could just pause the video if you need to complete those notes on the Venn diagram. You guys have a great day. Go Raiders. And make sure that you guys are encouraging Miss Moore. And even if you want, send an email to Miss Watson and just tell her that you hope she's doing well. She's really great. So see you guys. Bye.